Hi everyone, good evening. So I hope you are able to hear me. Can anyone please confirm?
Yeah, Basu.
Perfect. Okay, so as part of our demo, we have seen what we are going to discuss about data engineering. Throughout the 3 months that we are going to discuss, we came across it. Okay, so today is the first session, and there are few things that we need to talk basics before starting Azure Data Factory. So as I said, as part of our workshop, we talked about we are going to do two operations. We are going to do it. Or two problems we are going to face. So one is data storage. We are going to face a problem to store the data, and other is a data processing. These two will be there as part of our journey. So 80 to 90% of the time we are going to spend with the only data processing. Rest of them will be the data storage and some other activities, scheduling, many things will come into the picture. But most of the times we are going to spend with the data processing. So that means we need to know about data processing. Okay, so there is a very important concept that you are going to come across throughout your journey, that is ETL processing. So what does it mean, ETL processing? Okay, so I'm going to give better clarity about it. And then we are going to talk about ELT processing. What is ELT processing? And what are the technologies are available in order to talk with the ELT processing? And then we are going to see the different kind of how we can say that is a big data and what are the different platforms are there to provide the solution. We'll talk about it. Let's take an example. If I take a Flipkart, so Flipkart is going to have some application. Flipkart is going to have some application. Okay, you ordered some products. Even I'm also going to order. Most of the people are going to order the products, right? So most of you are aware of Flipkart and Amazon. So this application, we can call it as a business application. We can call it as a business application. So who is going to use this application is customers are going to use it. We're all the customers for their business. If you take a banking application or if you take a insurance, anything, for every business, there will be business application. So what this application is going to do is, this application is going to take the data from the customers. A day-to-day transactions are going to be collected through these applications. So day-to-day transactions are going to be happen with this application. If I wanted to transfer amount from one account to another account, if I'm having ICICI, then I have to use the ICICI application. We can transfer in various ways. That is used to run their business. And we know how we can use that application. We don't care about how data they're going to store it. So what these people are going to do is, they're going to have a system called OLTP system. So OLTP system means online transactional processing system. Online transactional processing system, they're going to keep the data into this database. This application is always going to interact with this system. The system is designed for specific to the business. So if they wanted to run the business, they need to have a system called OLTP system, which is used to call as online transactional processing system. So they're always going to collect the transactions data, a day-to-day data, they're going to collect it. We are not going to fall under this. We are not going to be falling under this. I mean to say, who is going to fall under this particular area is, I'm sorry. Application developers, we can say app developers. And SQL developers also is going to be part of this. As a data engineer, we are going to take the data from the OLTP systems. There may be single system, there may be multiple systems. So I'm just showing here single system, but we will be having multiple systems. In my project, we have more than 20 databases. Okay, we are having more than 20 different databases we're having in Oracle systems. Okay, so like that, you can have a data in the OLTP system. As the data engineer, we have to bring the data from this place. So your main target is to get the insights on top of the business. The business target is to get insights on the business. So that is the main target. They wanted to see the business, what is happening and how it is getting in. And if they wanted to compare the business with current month and previous month or current year with previous year, all this kind of historical data, if they need, the reporting system cannot maintain the historical data. So as a data engineers, we are going to do it. As a ETL developers, we are responsible to have the historical data. So like this, if you have a data in a different systems, then we need to collect the data from all the systems. So in order to collect the data from all these systems, we are going to use the ETL tools in the market. So there are many ETL tools are there. There are many ETL tools are there in the market. The process of taking data from this OLTP systems, we can call it as a extraction. This terminology is important because we are going to do ETL processing, or we are going to say generally data engineers are going to do the ELT processing. There is a difference between ETL and ELT processing. I'll talk about it. So we were having a different types of ETL tools in the market. Like SSIS, I worked in my experience, Informatica. So like this, there may be other ETL tools, DataStage. So like this, there are many ETL tools are there. So these tools are used to apply transformation. This is going to apply transformation. And we are going to have a database called staging database here. We're going to load the data into this. So this system, we can call it as a staging DB or operational data store. Operational data store. So the reason why we are going to have is we need to stage the data as your business systems are distributed or splitted into multiple platforms or multiple areas. So since the data was distributed in the OLTP system, we are just going to integrate or we are just going to keep it in a centralized location. Before going to maintain other transformations, we are just going to hold the data for some time in the traditional approach. And then in the second stage also, we are going to use the same ETL tools. People used to take it. SSIS or DataStage. Something like this we are going to have. And these tools will be again used in the second stage to apply the transformation. And then finally, they're going to load the data into the data warehouse. You're extracting the data from the system. Here also you're having extraction and transformation and then load. Okay, so there are many reasons are there to keep the data here. It's because if your source system is a file, we are going to keep the data in the staging database. There are many features are there. Okay, so decade ago, this is the only approach there was. There was only this approach to process the data to get the historical data. In this data warehouse, you are going to have a historical data and aggregated data you're going to have. I'll talk about the points here. So we are going to load the data here. From here, the reporting team is going to take the data. So reporting users are going to collect the data from this particular place. So now previously we were used to call as a ETL developers. Now the ETL developers are called as data engineers. Because this entire journey is going to process the data only. This is the place where we are going to sit. Previously we were called as a ETL developers. Now we are going to call it as a data engineers. Any question as of now? Is anyone having any question?
Hi, Bhaskar. Yeah, it is giving some basic information of ETL. Yeah, means I have a question on staging or operational data source you told, na?
Mhm.
And what is the main purpose and what are the features basically? You told means it is to just cleanse the data or there is a multi-purpose means that is the question means
Yeah, okay.
the
I'll
main.
give. Let's say, for example, your system may be file systems also. They may give the files in place of directly giving access to the database. They will export the data into CSV files, and the CSV files will be given to you. And if I wanted to join the data, then files are not allowed, right? So you have to apply many transformations. To avoid it, what we are going to do is we are going to keep the data in a single database. So if we keep it here, table 1 is coming from here and table 2 is coming here. If I wanted to join these two tables, the performance will degrade here. If I try to apply the transformation here itself. But if I apply transformation after having the data in the staging, then it is going to improve the performance. Many operations we are going to do because the database is a single database here. But here databases are there. Distributed system. Your staging is an integrated system. And this is also integrated system, but this is this is leaf level data we are going to have. And here we are going to have a higher level of data, aggregated data we are going to have it. Okay, so this is a traditional approach. So just keep in mind, there is a comparison with the same approach when I go with the medallion architecture in the data engineering. So there we are going to have a bronze, silver, and gold. So 3 different layers we are going to have, and how we can compare that particular layer, you can understand it.
Yeah, thanks. And you're going to cover up in future.
Yeah. We are going to.
The main
Now,
purpose basically, just to combine to
to
improve the
have a data in a single place. If I wanted to apply joins, I can write a SQL code here itself. But if you go and apply joins in the transformations, I mean to say in the tool,
landing area.
it degrades the performance.
So landing
Because
area basically just to copy the original data as is data,
yes,
and
that is
the
a landing.
cleanse also will do, or cleanse will do it in staging means after.
Yes. Okay, so slight difference you can feel when you compare with medallion architecture and this traditional ETL approach.
Okay, but yeah,
We are going to see.
it is
We are
same.
going to get a clear picture about it.
Okay. Thanks.
Okay. So now the problem with the existed ETL processing is these systems, these particular systems, whatever the systems I'm saying here, these systems are not capable enough to have the big data. I cannot store the big data here. That is one of the problems because these systems are monolithic systems, a single system. So data is going to store in a single system only. Even here also single system, here also single system. This entire process will go in a single system only. It will never go for multiple systems. So there is a problem to store the data. At the same time, the processing also is going to be happen only within the single system. You cannot process the data with multiple systems. So parallel processing is not available in the traditional approach, and data storage is also a problem. Okay, so and one more thing is this OLTP system or traditional systems are used to store only structured data. If I have a structured data, then I can only store the structured data. A decade, 1.5 decade ago, there was only structured data. So there was no semi-structured data, there was no unstructured data also. If you have a such kind of data, then these systems are not capable enough to process. That is one problem. Varieties of the data we cannot store in this OLTP systems. In the traditional approach, I'm saying, in the traditional systems, I'm saying. So I mean to say why we are coming out of the traditional system. That is what the main question that I'm taking here. And we cannot store the massive volume of data here. So what does it mean by massive volume of data? It all depends on your requirement. If your system size is 100 TB, then you can store only 100 TB. You cannot store more than that. If it is more than that, in that case, you can say with respect to your system, your 100 TB is the big data. Or if your system is can store only 10 GB data, then with respect to your system, for your system, if it is greater than 10 GB, then that is a big data for that particular system. And if I increase the storage, keep on increases, that is not going to improve the performance for us. it is going to degrade the performance. Okay, so if you add keep on storage for your laptop, even if you take a personal laptop, if your personal laptop is having 500 GB, if it is having a storage, if the storage is completed, you may think about why don't we increase the storage? And if the system is not capable enough to process is also is important. Not only storage, processing is also important. So if you're having a too much volume of data, if you're not having a processing capability, then there will be no use. So these problems were occurred like when the big data come into the picture. When the big data was introduced, then all these problems came into picture. Varieties of the data was not able to store, and we cannot store massive volume of data, and we cannot do processing parallelly. We cannot distribute the data. If the data is distributed with the different systems, you cannot process the data with this particular system. And there will be a lot of impact or a lot of issues were there in the traditional approach. So because of that reason, Hadoop came into picture, but I'm not going to talk at this time about Hadoop. At the time of PySpark and at the time of Databricks, I'm going to talk about it. So why we need to come out of this traditional approach to this one, and from this to here, we are going to talk about it later. At the time of this discussion, I'm going to talk. But I just wanted to give a brief idea about what is a big data. So for this one, what is the alternative to store the data from the Microsoft Azure? So since we are going to talk about the Azure, I just wanted to concentrate more on the Azure side. Okay, so how can you say that is a big data? Is basically there are 3 V's are there in the market to say that is a big data. One is value. So huge volume of data or huge amount of data, we can say it is a big data. I already told you, if your system is not capable enough to store, then that we can say it is a big data. And another one is varieties. I told you structured data was there in the traditional systems. When the Informatica was introduced or when the SSIS was introduced in the market, there were only structured data. Okay, so if you have a varieties of the data in your business, if you have a structured, semi-structured, and unstructured data, then these systems are not going to help you to store the data. So because of this reason, data lake came into picture. Hadoop distributed file system came into picture, HDFS, and ADLS. So since it is a ADLS, since we are going to talk about Azure, I'm just going to talk more about this one. But I'll give the differences between HDFS and ADLS at the time of Databricks discussion, because this is too early to talk about them. And we can store massive volume of data in the ADLS. We can store varieties of the data in the ADLS. And velocity. Velocity means the speed at which the data is coming from the systems. So how speed the data is getting generated in the business. If you take a Flipkart or if you take a Facebook, they used to generate the data like anything. So terabytes of the data they're getting generated, right? So that is also is going to be measured to say that is a big data. And this 2 more V's are there. I just kept it veracity, the quality or correctness of the data, how quality you're providing, you're having the data, but how much quality you're providing to the business users to get the insights on top of the business. And value, the data should be able to generate some business value for it. So these 2 you can ignore even, but these 3 are required for us: volume, variety, and velocity. So when you have this, any of this quality, any of this is succeeded, then we can say it is a big data. Simply, I wanted to say a data that cannot be stored in your system or the data that cannot be processed with your system is known as a big data. Okay, so these systems are not capable enough to store, and these systems are not capable enough to process the data. Because of that reason, we are looking towards to the different systems. Is everyone with me? I hope
Yeah,
everyone.
yeah.
Perfect.
Please come. Other people, please comment. Yeah. Just to understand on veracity and value. So can we say like correctness of a data means suppose we are expecting some float values. Example, 0.001 or only that one, but it came as a negative. Maybe that is the not
Yeah,
the
of course.
correct.
That is what it is correctness.
Okay.
Let's say
And
there is a one business user.
hmm,
He is the business analyst or he's the salesperson. He
hmm,
sold 10 products.
hmm.
Okay. But in the report, they're having only 8 products.
Yeah.
There
Okay.
is no the data is inconsistent.
Okay. That is
Okay,
also.
so for this
Yeah.
one, you have to process the data as early as possible. Then only we can see the same data.
Hmm.
Otherwise, there will be conflict. If you're processing, if for processing itself, if you're taking 2 days or 3 days, then
Hmm.
there is no point of finalizing the report also.
Yeah. And
So
where? Yeah.
yeah, please
Go
go
on.
ahead.
Yeah, please go ahead. Yeah.
Yeah,
But that is
so we have
veracity.
to show the
Yeah.
exact accurate values.
Yeah, got it. And value, can I say like,
Yeah, something
it is
like,
in yeah.
if you're taking, once you cleanse the data and once you kept it, and the business users are reporting a team, they're going to generate the report. They're expecting some value on top of the business to grow in the business. If they
Hmm.
wanted to grow in the business, definitely they have to get some value out of the data, because data is like a fuel.
Hmm. So we can say they're expecting some attribute, or you are saying means maybe it is beyond that.
Yes, of course. So something like they wanted to compare the business with current month and previous month. They have to
Okay.
collect the data from they're running the business across the globe, and you have to bring in different places. You have to apply data cleansing, you have to apply joins, many things. And then finally the data is going to show in the report.
So it cannot be like single value. It can be combination of something which
So
gives
value
the
means it's
business
not a
value.
single value, it is
Yeah,
a many things.
got
The
it.
value of the business.
Okay.
Okay. So these things are going to be done. This particular part will be done by the report, but we are responsible to give the data to the reporting team.
Hmm.
Okay,
Yeah,
so
better.
data engineers are responsible.
Okay.
Okay, so let me move forward.
Thanks.
Now, what are the advantages of your cloud systems if you go to the cloud systems? Okay, so let's say, for example, you are having SSIS. Most of you are aware of SSIS or Informatica. I'm just taking Informatica, or even Hadoop you can take. For all these systems, you need to have a storage. On-prem storage is required. And on-prem system is required to process it. So that means to have all these systems, you need to have a few things. Like if you wanted to have this one, you need to have a servers are required. Okay, so infrastructure is required. Networking team is required. And cooling systems are required. And security is required. So I'm just giving few of them. If you wanted to start any business, or if you wanted to provide the solution for your data, in order to go even with the traditional systems, you need to have your own platform. If you have your own platform, then only you can specify or you can use that particular systems to provide the solution for your data. I have a data to provide the solution for your data. If I wanted to use the Hadoop, then you need to have a cluster. So multi-node clusters are required. Or if you wanted to go for Informatica, then you need to have a system. So without server, you cannot set up it. So that you need to take care about it. And then you are going to do the processing. For all these things, what you required network is required, cooling system is required, security is required, power is required, building is required. Everything is going to be within your premises is required. So that is very difficult. Okay, so even if I wanted to do the POC also, you required many things if you go for on-prem. So whatever is there within your premises, that is what it is on-prem. So let's take an example. If I wanted to stay in the Bangalore, I don't need to buy a house. I can stay in the hotel. Once my work is completed, I can come back to. So that is one of the example. Or if I wanted to take a power to my home, electricity power, I don't need to buy a electricity power station. I'm just going to take a plug and play. I'll take a power, and whatever the I consumed, for that I'm just going to pay it. So many benefits are there if we go for cloud systems. We can avoid all these things. There are many things which is there in your premises. We can take out and we can reduce the cost. So because of that reason, many companies are moving towards to the cloud systems. So we don't need to care about redundancy. We don't need to care about upgrade. We don't need to install any operating systems. So there are many features are available in the cloud platform when you go to the cloud platform. So I just gave some example here, scalable. If I go with the cloud, what are the advantages? So I'm just giving few options, few advantages here, scalable. The scalable means, let's say, for example, I've taken a SQL server from the Azure. Just imagine the basic pricing tier I have taken. We are going to see that what do you mean by basic pricing tier, or what are the different types of configuration we can go for, and we can upgrade also. If I wanted to upgrade it, for some reason, if I need little more configuration for just 2 days, I can increase the compute for 2 days. Later 2 days, I can bring it down to reduce the cost. So whenever I wanted to increase the compute, I can increase, and whenever I wanted to decrease the compute, I can decrease it. So that flexibility is available in the cloud systems. But when you go for your on-prem, if I have a 100 node cluster, and for some reason, if you wanted to increase this to up to 50 node, I mean to say 100 plus 50, 150 node, if you increase it, then you cannot decrease it because this is your own systems. If you have some other purpose to utilize it, then that's fine. Otherwise, there is no use of it. Of course, you're going to use it, but still you're going to waste it if you're not going to use them. But when it comes to here, if I wanted to use that, I can use. If I don't need to use it, I can take it out. Okay, so I'll talk more in detail. What is the difference between Spark and Hadoop? Then you can understand how the cluster is going to work in the Hadoop and how the cluster is going to work with the Spark. Why Spark is famous and why Hadoop is getting completely down in the market. So I don't even think about 5 to 10% in the market, because maybe if there is existed projects, I'm not exactly sure. But many people are saying, even if you get a chance to work with the Hadoop, you can just ignore and go for others. So it was almost replaced. The Hadoop was almost replaced with the Spark, especially the MapReduce. Your HDFS remains same, and your resource manager is remains same, Yarn. And there is a MapReduce. This MapReduce, this MR is reduced. MR is replaced with the Spark. So we are going to talk about it later. So here the scalable means whenever I wanted to increase the compute, I can increase it. And whenever I wanted to decrease the compute, I can decrease it. Capital expenditure and operational expenditure. So capital expenditure is more when you go for on-prem, and when you go for on-prem, it will be capital expenditure is very, very more. And of course, even operational expenditure also you're going to have it. But when you go to the cloud, you're going to have only operational expenditure. And if I don't need it, I can just take it out. Okay, so then we have agility, like how fast you're going to set up the environment. We're going to have with just a few clicks, we can set up it. But when you go for on-prem, it's not that easy to do it. Okay, so that is one. And geo distribution or geo replication we're having. And if I wanted to do the same thing with on-prem, let's say, for example, if I have a database in the India, then same database, if I wanted to keep in US, then you have to invest it. There is a more and more cost you have to take care. But that is very difficult. But if you go with the cloud, you can replicate this database into the different regions. Depends on your requirement, you can keep that in the different places. And disaster recovery also will be there, since there is a geo distribution or geo replication. If any of the reason is failed, then we can get it. We are going to talk about it little more details at the time of ADLS Gen 2. And cloud is a completely cost effective. Okay, so very, very less when you compare with others. Now, if I wanted to take the services, if I wanted to take the storage services, because as we are going to work as a data engineers, we need to think about the storage and processing. So that means cloud systems are providing many services to the customers, but we have to take only storage services and processing services. These two only we need to concentrate. Now I have a cloud. I wanted to take the services from there. If I wanted to take the services from there, then you need to understand what are the different types of cloud systems we're having in the market. But mostly we are going to use only public cloud only, 99%. So public cloud is important. Microsoft Azure is a public cloud. Amazon AWS is a public cloud. Google GCP is a public cloud. That means, so Microsoft branding their services with Azure, and I can take the service from here. You can take the service from here. A company also can take the services from here. Everyone can take it. A company can take the service, and I also can take the service, and you also can take the service. So this kind of cloud systems, we can call it as a public cloud. They're open for everyone. So Microsoft Azure is a public cloud, AWS, Amazon AWS is a public cloud, and Google GCP also is a public cloud. If I wanted to store the data, basically from the Microsoft Azure, we have a ADLS Gen 2. I'll come across the list of services. If I wanted to take this service to store the data, then I have to use the public cloud, because it is a Microsoft Azure is a public cloud. And there is a private cloud also. Basically, this private cloud will be used within the organization. Okay, so for some reason, if the customer is not interested to have the solution from the cloud systems, they can go for private cloud. So for example, just imagine I have a customer. I have a customer A. This customer A is contacted with some company, service-based company. You just imagine service-based company. So he wanted to get the solution for his data. He has the data. He wanted to get the insights on top of the data. He wanted to process the data. So he contacted one service-based company. And based on this customer requirement, they're going to have a service, to say solution architects will be there. Okay, so many people are going to sit together. They're going to come up with the solution for their data. They're going to come up with the plan. So just imagine according to their business, they're going to give the solution. If they have a less budget, if they're fine to go with the cloud systems, then they can suggest accordingly. Sometimes this customer also will be aware of it. Customer themselves, they're going to decide, I wanted to go with the GCP, or I wanted to go with Microsoft Azure. They will come up with some extension. Okay, so I wanted to go with the Azure. Then definitely we have to provide the solution according to the customer requirement. If the customer is not interested to have a cloud platform, if they wanted to keep within their premises, but they're not having their own premises, then what they will do is they're going to take the, let's say, for example, I'm just going to take an example, TCS, or any company can take it. If they have already a data center, this TCS will give the data center to that particular company only. These people are, these private cloud vendors will never give the services to others. They will give the only to the companies. Only organizations only can take the services from the private cloud. So these people will never give to the individuals. If you wanted to take it, if you want to take it, then you have to go for public cloud. But the problem here is they don't have a services. They don't have a cloud services like Microsoft Azure services. If the customer is interested to have a Hadoop, then they will set up the Hadoop and they will give the access to their cluster. I mean to say for their environment. Or if the customer is interested to have a Oracle system, they will set up the Oracle. They will take the license. I mean to say, of course, the license cost will be paid by the customer only. They're going to set up it. They're going to give the environment for you. So in that kind of situation, people used to go for private cloud. Everything they're going to keep in that particular place. For some reason, if they're not interested to move, or if for some reason, if they wanted to have their own platform, then they can go for private cloud. And here are some limitations. If they wanted to increase the compute or decrease the compute, it's not that easy to do it. So they may not do by themselves to increase or decrease. You may need to raise the request in order to do it. So many limitations will be there. And the cost is very huge. When you compare with on-prem, that is little better, but still that is going to be little more cost. So there are more than 90% of the companies are interested to travel with the cloud only. So because of that reason, we are having many openings in the cloud systems. So not only that, if you go for the cloud, they're having a varieties of the services to provide the solution for your big data. If you take an example, from Microsoft, we have a ADF, Azure Data Factory, to provide the solution for your big data. From the AWS, I have a Glue to ingest the data from the varieties of the systems. Or I have a Azure Databricks to transform the data. Here also some other softwares may be there. But those kind of systems are not available in the on-prem. So Data Factory is not available in the on-prem. You cannot install something like SSIS or Informatica. SSIS is a software you can install, but Data Factory is not like that. It's a platform. They're going to give a platform to you. So we are going to talk about it. And then third one is hybrid cloud. So hybrid cloud means when you combine or when you take the services from both public and private, in that case, we can say it is a hybrid cloud. But basically hybrid cloud was not existed. Only public cloud is existed, private cloud is existed. When you take for some reason, when you're taking the service from both of the services or both of the platforms, in that case, we can say it is a hybrid cloud. Okay, any question as of now?
Yeah, hi Bhaskar. One question, like when you mentioned ADB or Azure Data Factory, so it is not available in the private cloud.
No, it is not available.
That is the way, means they will build. It will be non-accessible to the outside the organization. That is correct.
No. You can access it because that is a public cloud, right?
No,
ADB and
private
ADFC is a public cloud.
No,
Private cloud is not having that.
Yeah, that is what the difference between
Yes.
public and private.
Yes.
And what is the reason? Only like data secure. That is the only reason, right? We need to build a private cloud. Means for the organization.
Basically Microsoft or any cloud vendors are going to provide 100% security.
Yeah.
But still some people, if they have a very sensitive data, if they are not interested to store in the cloud, and some part of the storage, they're going to keep it in one place in their premises, and other set of process, they may do it with the cloud, so that they can reduce the cost. So some sensitive data like Aadhaar card numbers or SSN numbers,
sensitive,
credit card numbers, this kind of things, they may feel, why we need to keep in the cloud? Why don't we keep in our systems, in our premises?
Okay, then in that time they will go for hybrid.
Yes, they will go for hybrid.
And TCS you mentioned, na? So like Microsoft, Amazon, and Google also, they can provide the private cloud also.
No, they don't provide. They provide only public cloud.
Okay.
They wanted to brand it.
Yeah. Thanks.
Yeah. So now I'm just going to talk few more things here. When I talked about ETL processing, we have seen OLTP system. Two systems I'm going to talk. This is a OLTP system. The very starting of your business is going to be happen here. And this is a DWH, or we can also call it as a OLAP system. So this system is specifically designed for business. If you wanted to run the business, then you need to have this system. And this system is designed for analysis. To analyze your business, we are going to use this system. So transactional data is going to be there here. Okay, so there is a chances to ask in the interview, what are the differences between your OLTP system and OLAP system? So this system is designed specifically for only running of the business. So without OLTP system, you cannot run the business. The design itself, both are databases. This is a database, this is also database. But the purpose of this database is to run the business, and the purpose of this database is to analyze the business. Okay, so who is going to use this particular system is all the business customers are going to use this particular system. But this one, business users are going to use. The part of the business, the people who are part of the business is going to use this particular system to analyze their business. So the first point I'm saying, transactional data is going to be there in the OLTP system. And when I say OLTP means it is an online transactional processing system. Whatever the data is coming through your business application and sitting in some storage, that storage we can call it as a OLTP system. And I told you all these OLTP systems are going to have only structured data 100%. Only structured data you're going to have it. And this system is going to have a day-to-day transactions. To handle the day-to-day transactions you're going to have here. But in this particular place, we are going to have a historical data. Historical data you're going to have. So recent data or day-to-day transactions you're going to have as part of this OLTP system. And for example, you can take online banking transactions or Amazon applications, Flipkart applications, insurance, any business you can take in the market. So in order to run any business, definitely they need to have a database called the OLTP system. To design this particular system, they're going to use ER modeling. ER modeling means entity relationship modeling. The modeling decides is that OLTP system or not. We are not going to have a duplicated data here. We are going to have 100% unique data. So no duplicates will be available. Whereas here, you're going to have a dimensional modeling. So I'll talk about what is the dimensional modeling at the time of our project, because we're going to have a dimensional modeling, facts and dimensions, we're going to have it. And this system is going to have a historical data. I already gave it. Historical data, you're going to have it. So that means duplicated data will be there. So duplicated data means, for example, if I take a 101 customer, so address is some address 1, but later some point of time he moved to address 2. So customer is same, customer details is same, but address is changed. So this is the old address and this is the new address. So old address is there and new address is there. So in that perspective, we can say this system is going to have a duplicated data. Otherwise, we cannot track it. We cannot analyze your business if you don't have a historical data. So example for your OLTP systems is Oracle systems, SQL Server, MySQL. There are many databases out there. And even for data warehouse also, we are going to have, we can use basically SQL Server also we used for data warehouse. And we have a Netezza in the market. Our Teradata is there. It was very famous that point of time, decade ago. And if I wanted to write the data into this table, if I wanted to write the data into this OLTP system, 100% schema should be there. 100% schema should be there. So schema means the column, number of columns, the data types of the columns, the size of the columns is going to come under the schema of the table. So if you don't follow the schema, then it will not allow you to feed the data. So we are going to come across at the time of SQL sessions. Okay, so schema and write. If you want to write the data, you have to follow 100% the schema. If there is a 3 columns, you have to enter the values for only 3 columns. If there is a 5 columns, you have to enter the data for 5 columns. Or you have to specify for what columns you wanted to feed the data. So data types are fixed. Data types are fixed for the columns. If I try to enter some text value here, it will not allow to load it. Okay, here also if I try to add some date values, then it will not allow to add it. Because there is a schema on write. If the incoming value is not matching that particular data type, then you cannot write the data into the OLTP system. In the same way for data warehouse also, because both are databases. The only difference is this is for analysis purpose and this is for running of the business. And here we are going to have a historical data and duplicated data. And here we are going to have a less number of tables, very less number of tables. And here we are going to have a more and more number of tables. So that is what it is. The cost is common for both of them. Both are high cost only. Okay, so if the schema is mismatched, then you cannot feed the data into the tables. So that is about OLTP system, and data warehouse also mostly I just covered. You can have many of the points are same. So analytical processing, where we required a lot of historical data to find the insights. That means in order to get the insights, we need to have a historical data. So if I wanted to show based on the month, then each month data is there, should be there. Then only can do it. So we are going to have a complex queries because we are going to have a very less number of tables, and at the same time, like we'll be having a dimensions, facts and dimensions. We are going to have a spot of this. We take the data from the databases and migrate it to data warehouse to do the analytical processing. That is what we discussed. If you have a multiple OLTP systems, in order to load the data into the data warehouse, you are taking data from all the systems and integrating and loading the data into the DWS. So these particular systems, we can call it as a OLTP systems. So here also we are going to have a structured data. And data is coming from multiple systems, not from single system. It may not come from the single system. So definitely it is going to get from multiple systems. Okay, so schema on write same, and ETL processing we are going to apply to load the data into this particular system. And to bring the data here, you will be having a business applications. Example for your DWH is Teradata. So here also the cost is high, but when you compare this, when you compare with your OLTP system, this will be less. Okay, so the data lake, why data lake came into picture is because this data warehouse and OLTP system both stores only structured data. So I don't want to follow the structure. I don't want to follow the schema. I just wanted to dump it. So if you wanted to dump the data, then you can go for data lake. So we are going to say ADLS Gen 2, we are going to talk about it. ADLS Gen 2 is your data lake. Your HDFS is a data lake, or your Amazon S3 is a data lake. Okay, so from Google also we have a data lake. So the data is going to be in the form of raw, is going to store it. We are going to see each and every point, and we can store structured data, semi-structured data, and unstructured data. These data is not going to be possible in OLTP and DWH. So log files, like if you wanted to store the log files, because logs are going to store how exactly that log is going to be generated. Means like if you have some application, the logs will be captured, and if they wanted to analyze the logs, business logs, then they're going to store the log files in the data lake. So from here, we are going to see the ELT processing. What do you mean by ELT processing? When we touch the data factory, then I'm going to give a better clarity about it. So for this one, examples I have given ADLS Gen 2, HDFS, Amazon S3, and so on. So these systems are cost effective. Data lake is cost effective because it is like a lake. You can dump anything. The price is less, very less when you compare with your on-prem systems or databases. And these systems are important to read the data, because schema is required only when you read the data from this particular systems. But to write the data into these systems, we don't need a schema. Okay, so it is more and more flexibility. We are going to talk more in detail about this Azure Data Lake Storage Gen 2 on tomorrow. And I'll talk about Azure introduction on tomorrow. Okay, so this is brief idea about what is the differences between OLTP systems and OLAP system and data lake. Any question, guys? I have 2 minutes.
Yeah, hi Bhaskar. Yeah, like difference between OLTP and OLAP you told, right?
Mhm.
So I think there is a one normalization and denormalization.
Exactly.
That is also
So that
one.
is also there. Normalization will be there in OLTP, and whereas in OLAP we will be having denormalization. That is what it is, a duplicated data.
Yeah. And in that denormalization, one like clarity, like there are two types of denormalization. What I heard, please correct me if I'm wrong.
Yeah,
Like
please.
one is like where we have you highlighted like SCD12 when we implement historical data, there is a duplication. And same way, like when we have a like example customer data, like some personal data like name and age, it will be in one table from the OLTP, and set of other details with respect to customer, it will be present in other table. When we are joining in the data warehouse, that key or the customer ID maybe or the name, something it will be duplicated when we are joining multiple tables, right?
Yeah, that is right.
So that is
Basically,
also, yeah,
that is also like, splitting the
denormalization.
dimension. Like in the data warehouse, you can have a up to some level normalization also is possible when you split the dimensions into multiple dimensions.
And same way when we are
Snowflake.
yeah, this is with respect to like rows. Same way it can be denormalized. We can say when we combine the multiple columns into the single table, then also we'll say denormalization or no. I mean
Denormalization.
that is also two types of like row wise and column wise, right?
Yes.
Is that correct? Okay.
Okay, but when it comes to the data lake, we don't care about normalization, denormalization. We're just going to dump everything.
Yeah, while writing. Yeah,
Yes.
only while reading. Yeah, we have to consider as a schema.
Yes.
Okay.
Okay. So I'm going to give little more clarity on tomorrow. It's time to join my meeting.
Yeah,
I'm
sure.
stopping here. I will see you on tomorrow.
Thanks very much.
Thank you for joining. You can use the same meeting link for tomorrow.
And where can we get these recordings?
I'll share the details. That's it.
Okay, okay. Thanks.
Yeah. Thank you.
Thank you.